There are two things we want to do with this function here, 10 to the x. First of all, we want to determine what is f of 2, so we're going to take the 2 as we know and replace all the x's with that 2. Here's what that looks like. We're going to have f of 2 equals 10 to the 2, which is 100. So we're going to claim then that f of 2 equals 100. And the second thing is we want to determine, is 10 to the x a growth or decay function? Well, here's what we've got. We look at the base first. I see that the base is bigger than 1, and the exponent is positive, or I could write it actually like this, 1x. So what we have here is that the base is positive, the exponent is, the coefficient of the exponent is positive, so this function is a growth function. And growth functions, we know, look like this. So first of all, we'll claim that f of 2 is equal to 100. And secondly, we will claim that 10 to the x is a growth function. And in number 2, the first thing we want to do is find f of 5. So we're going to replace this x and all x's with a 5. So that will give us f of 5 equals 0.98 raised to the 10 times 5. So that's 0.98 raised to the 50th power, and my calculator is giving me, when I do this, well, I'm getting 0.364169, so on. But what we're asked to do here is to round to 3 decimal places. So I'm going to round to that place right here. So I'm going to claim that this is 0.364. And secondly, is this a growth or a decay function? Growth or decay. So look at the base. The base is between 0 and 1, and the exponent is, the coefficient is positive. So between 0 and 1, this is positive, so this is going to be a decay function. So I'm going to claim now that this function is a decay function, and decay functions look like this. And in number 3, we're going to find f of 2 for this function here, and right away I'm seeing this as what? Growth or decay. This base is between 0 and 1, the coefficient of x is positive, so I'm thinking, okay, between 0 and 1 decay, positive decay, so it's going to be a decay function. And I'm just going to put the 2 in for every one of those x's. So we're going to get f of 2 is equal to 1/4 to the 2 minus 1, right? I put the 2 right in here, so 2 minus 1. So we're going to get 1/4 to the 2 minus 1 is 1, so we just get 1/4 out of this. And then because the base is between 0 and 1, and this is positive, we're going to have a decay function. So I'm going to claim this function is decay, and decay functions we know look like this. Number 4, we're going to find f of 2 for this function. Now, just as I look at this, I see that this base is bigger than 1, so I'm thinking growth, but then I see that the exponent, the coefficient here is negative, so now I'm thinking negative growth. Well, negative growth, that's the opposite of growth, that's decay. So I can see right away this function is going to be a decay function, looking like this. And now I'm going to substitute the 2 in for the x. So we're going to get f of 2 equals e to the negative 2. And I can do this one on my calculator. So I'm going to get, and I'm going to round to 3 decimal places. So what I get here is 0.135.